Hi, in this video we are going to discuss how to divide complex numbers. So I have separated the questions into two types. The first group or type is when you have only one term in the denominator. What do you do? So first, question number 1, we have phi over I. There is only one term in the denominator. So whenever you have only one term in the denominator, all you have to do is whatever is in the denominator, the imaginary part, you have to take that and you got to multiply it to the denominator and the numerator again to the fraction like that, above and below. So in the numerator you get 5 times I is 5i, and the denominator you get I to the second power, and we know that I is defined as square root of -1 and I squared is defined as square root of -1 squared. So the square and the square root cancels and the value of I square is nothing but -1. So in the denominator, it becomes phi I over -1. And when you divide phi by -1, you get negative phi I. So that's how the answer becomes. The reason why you cannot have I in the denominator, because I is an imaginary number. There are 3 things you cannot have in the denominator. Okay, 3 types of numbers. You can never have a 0 in the denominator. You cannot have an irrational number in the denominator. You cannot have imaginary numbers in the denominator. It's not defined. So if you have 0, it will become undefined. If you have irrational number, you can rationalize the denominator. There is another video about that. We've already done it. And if there is an imaginary number, this is what you should do to try and get rid of the imaginary number from the denominator. So that's question number 1. Let's try question number 2. If you look at the denominator, you can see that there is only one term. There is a coefficient of -3 and an I. So how are we sure that the denominator is one term? It's -3i. It's not like -3 plus I. This would make it 2 terms. And this just means that there is one term in the denominator. So be careful how you count the number of terms. They're separated by positive and negative signs. So let's look at the second question now. So we have -7 over 3i. So -3i. So we take the I and we multiply it to the denominator and to the numerator like that. And then I'm going to put it in parentheses like that, so you can see that I multiplied an extra I. So here in the numerator, we have it as -7i. In the denominator, we have it as -3i squared. So that makes it -7i in the numerator, and in the denominator, the I squared becomes -1. I squared changes to -1. So -1 times -3 becomes a +3, and that's it. We don't have any more imaginary in the denominator. So that is done. Question number 3. Again, there's one term in the denominator. It's -2i. So in order to divide that, we write the question here, -2i. So we take the I and we multiply it to the denominator and to the numerator. The only thing that's different here is that the numerator has 2 terms. So we put that in parentheses because the I is for both of them. Alright? So how we deal with this is we distribute the I to the 6 and distribute the I to the I. So we have 6i minus I to the second power over, we have -2i to the second power. And wherever we have I to the second power, we're going to write it as -1. So I have a 6i minus I squared becomes -1. So make sure you put that in parentheses so you will not forget to put the -1 there. And the denominator you have -2 and I squared becomes -1. So here we can write it as 6i. These 2 negatives will become a positive, so it's just +1 over the denominator, the -2 times the -1 becomes a +2. So that is the answer for question number 3. Now we are going to discuss, since we are done with type 1, we're going to discuss type 2 when the denominator has two terms. There are two things which will help us to do this. We have to recall what do you mean by conjugate, and we have to recall the identity a plus b, a minus b, which is equal to a squared minus b squared. So we need to know these two facts. So let me write down a question here. For a question, I'm going to put as phi over 3 plus 2i. Okay. So here in the denominator we have two terms, 3 and 2i, 3 plus 2i. That's a two-term denominator. So whenever you have a two-term denominator, the first thing, the steps, I'm going to write the steps here. The first thing you do is you have to multiply. Instead of multiplying just with an I, you're going to multiply with the conjugate of the denominator. If you recall, conjugate of a plus b is a minus b, and conjugate of a minus b is a plus b. So whatever is in here, the complex conjugate of 3 plus 2i is nothing other than 3 minus 2i. So we'd multiply by 3 minus 2i above and below the fraction, like that, in the numerator and in the denominator. And here we have 5, 3 minus 2i. I'm not distributing the 5 into the numerator yet. I'm not distributing it yet in the numerator. In the denominator, you have 3 plus 2i and 3 minus 2i. So this is of the form a plus b and a minus b. So we're going to apply the second step here. Step number 2, you have to apply the identity a squared minus b squared. So whenever you have a plus b times a minus b, you can write your answer of the form a squared minus b squared. So instead of a here, we have 3. So we will be putting 3 to the second power minus, instead of b, you have 2i. So you're going to put 2i to the second power. Okay, so that's how we would write the denominator as. And then in the next step, we can just write 5. We don't have to distribute it. You can leave it just like that. 5, like that. And then here 9, 3 squared, we will get it as 9. Minus 2 squared. The square is for the 2 as well as for the I. So 2 squared is 4 and I squared is negative 1. So that becomes a negative 4. And the negative and the negative 4 in the denominator, it becomes 9 plus 4 now. So your final answer just becomes 5 times 3 minus 2i, and the denominator becomes 9 plus 4, which is 13. There is nothing else we can simplify. If it was possible to simplify 5 and 13, we would, but we can't here, so we are done with the problem number 1. Let's do one final problem. Another question also. So let's do 1 plus I over 3 minus 5i. 3 minus 5i. So again, rewrite the question one more time, and then step number 1, you have to multiply with the conjugate of the denominator. So the denominator is 3 minus 5i, so you're multiplying with 3 plus 5i in the denominator and in the numerator. So whatever is in the denominator, you got to take the conjugate of that and then multiply it up and down. So if you look at this in the numerator, now we have two terms. In the numerator, when you have like this, I'm going to write the third step like that. It's not actually the third step, but when you have two terms like that in the numerator, you can just distribute and multiply. Distribute and multiply. Distribute means multiply. I would just say distribute and combine. And in the denominator, you just have to apply what we did before, step number 2, a squared minus b squared. So let's see what we can do here. We have 1 times 3 as 3, 1 times 5i as positive 5i, And then we distribute the I times 3 as positive 3i, and I times 5i as positive 5i squared. So we distribute it here because they're both two terms here. Okay. In the denominator, we are going to apply a plus b and a minus b. So this is our a plus b on this side, and on the front is a minus b. It doesn't matter which order you write it in. As long as you have a plus b times a minus b, you can apply the identity a squared minus b squared. So instead of a, we have 3, so we put 3 square minus, instead of b, you have the imaginary part is 5i, so you put 5i squared like that. And here, remember, we have to simplify the terms. Whenever we have I squared, we can simplify it as negative 1. So in this last term right here, since I squared is negative 1, that negative 1 times 5, this just changes the last term to negative 5. So the numerator, when you combine the real, it becomes 3 minus 5 is negative 2. And when you combine the imaginary parts, 5i plus 3i becomes 8i. So that is your numerator. In the denominator, let's square the 3. 3 square becomes 9 minus, let's square the 5, it becomes 25. When you square the I, it becomes negative 1. So this becomes a negative 25. So 9 minus of negative 25 becomes 9 plus 25. So we get our answer as negative 2 plus 8i over 34. 9 plus 25 is 34. Usually we are done here, but in this case we can see that the numerator has 2 as a common factor, and so does the denominator. So I can take 2 as a common factor away from the numerator from both of them. So when I take away the 2 from the numerator, I get a negative 1 as my first term, plus 2 times 4 is 8, so I get 4i as my second term. In the denominator, I have 34, and we know that 2 and 34 reduces, 2 goes into 2 once, and into 34 17 times. So my final answer becomes negative 1 plus 4i over 17. Okay. So this is how you would divide complex numbers.